Hello everyone. On this video I'm going to go over the different types of multipliers. We're gonna start with the first type, which is a closed economy multiplier that has government purchases and tax, lump sum tax, a tax amount multiplier. The second one is again a closed economy but has a tax rate instead of tax amount. And then the third one is the open economy multiplier. So in all of these multipliers, we have an important assumption that prices do not change. So when we start with the first one, which is the closed economy multiplier with lump sum tax, we have a simple model. When we say a closed economy, we don't have net exports. Okay, we know that consumption has a certain intercept and slope. We used to write it as A plus BY, where this one is the intercept and this one is the slope. We're going just to use a more general form by saying the intercept is C bar and the slope is the marginal propensity to consume. So we're going to write it this way. So Y is equal to C bar plus MPCY plus I plus G. And then we can take Y as common factor from, take it to the other side, and then take it as a common factor, and then we're left with C bar plus I plus G. And we can write the multiplier as 1 over 1 minus MPC, as we have seen it before in one of the previous topics, right? And then this is multiplied times C bar plus I plus G. So out of this formula, we can say that anytime we have a change in the government spending, output will change, right, by the amount of the multiplier. Right? It's like you're taking the first derivative of this equation with respect to G. Okay? And this we call the government multiplier. Okay? In this simple model, we don't have any taxes, as you can see. Like we're just taking a certain amount of income, where income here is just like the full amount of the gross income without taking taxes out. Okay, suppose that the government is offering a lump sum tax. Okay, so we can expand the model by adding a lump sum tax. So we can say that how about if we have C plus I plus G, but now we have a certain amount of tax that is affecting my consumption. So I have a C bar plus I have a marginal propensity to consume that is not just multiplied times Y, but it's multiplied times Y after I take out a lump sum tax, a certain amount of tax. It's not a rate, it's amount of tax in dollars, plus I plus G. This is what we call YD, disposable income, right? And then we proceed with this equation by typing as C bar is MPC times Y minus MPC times T, right? Plus I plus G. And we can continue with this equation by taking Y as a common factor, as we did before. So it's going to be like Y 1 minus MPC, and we're left with C bar, right, minus MPC times T, right, plus I plus G. We can write it in a nicer way by combining anything that has MPC in one term. So we can say that Y is equal to minus MPC times T over 1 minus MPC, right? And this is plus C bar plus I plus G. And out of that, we can say that the changes in Y because of the changes in a tax amount is going to be equal to minus MPC over 1 minus MPC. And this is, we call it the tax multiplier. Okay, so that means we have two types of multipliers. As of now, we have the government multiplier, which is the simple one, 1 over 1 minus MPC. This is the government multiplier. And we have MPC over 1 minus MPC, and this is what we call the tax multiplier. Okay, so let's see the slides. So if we assume that we have these numbers and we have consumption, the autonomous part, the fixed part is 2000, the MPC is 0.75. In other words, you are going to consume 75% of your disposable income. You're given that investment is 2000, government spending 2500, a lump sum tax amount of 2000, and the equilibrium condition, as we know, is C plus I plus G. And disposable income is Y minus T. All right, so assuming that we want to solve for Y, so you just plug in all the variables. So this is C bar plus MPC Y minus T plus I plus G, right? And then you have all the numbers, and then you take this to the other side. So it's going to be 1 minus 0.75, and it's going to give us 0.25, and then you can compute out of this the equilibrium real GDP or equilibrium Y. Okay, and this would give us, based on the numbers, 20,000. The general approach of writing it is just writing it in letters, right? So every time we're writing it in a general way, we're just writing C bar, that stands for the autonomous consumption, I bar autonomous investment, G bar autonomous government spending, T bar is the autonomous tax amount, and this part is called the induced part of consumption because it depends, this is the amount of consumption that depends on disposable income. So everything that has a bar does not depend on income, but doesn't have a bar, then this is called induced part, or the part that does not, the part that depends on income. Okay, so the autonomous values are the parameters that are fixed, that do not depend on income. All right, so this is like what I did on what I wrote on the slide. So you can always solve for a tax multiplier, right, by taking the 1 minus MPC out, and then you can have it as in terms of changes, then you can have it as minus, this is the tax multiplier, right? So minus MPC over 1 minus MPC. Okay, and this is like a general form. Okay, so and the tax multiplier is the one that I derived in on the slides, and I said that the government multiplier is 1 over 1 minus MPC. So if you're given MPC is 0.75, then you can compute the government multiplier as 4. So for each $1 increase in government spending, output is going to increase 4 times. For every 10 billion increase in government spending, GDP is going to increase by 40 billion. 10 billion, 40 billion. Okay? Okay, so yeah, and this is for the tax multiplier that we discussed in the previous slide. And again, you can plug in some numbers, and as you know, because we have a negative relationship between taxes and income, the higher the tax, the lower the income. So we always expect that the tax multiplier to be negative. Okay, and the tax multiplier is negative MPC over 1 minus MPC, and you can solve it using 0.75. You're going to get it as negative 3. So for each 10 billion increase in taxes, GDP is going to decrease, it's negative relationship, by 30 billion. Another important discussion is the balanced budget multiplier. What is the balanced budget multiplier? We know that the increase in G would increase real GDP. However, the increase in taxes would decrease GDP. So we have a positive impact and a negative impact. So the question is, if we have a government spending increase by 10 and an increase in taxes by 10, right? So I have a positive impact by 10 billion and a negative impact by 10 billion. So the impact of government spending on Y would depend on the multiplier effect, or the government multiplier. And the impact of taxes would depend on the tax multiplier. So let's see that. So we have a positive part, 10 billion times the tax times the government multiplier, and we have a negative part, which is the 10 billion times the tax multiplier. You can combine all the MPCs together and you can solve it. You will end up by 2 terms being cancelled, and the change in Y would be equal to 10 billion. And this one is telling us that anytime I have an equal increase in government spending and taxes, okay, by the same amount, it would have the same amount of increase on output, and that's what we call the balanced budget. So for example, again, just making the same number, the change in Y would end up by being 10 billion, which is equal to the increase in government purchases of 10 billion and the increase in taxes of 10 billion. Okay, this is a short-run effect, and the short-run effect is telling us that there would be an increase in GDP by 10 billion. However, the long-run effect is 0. Why is it 0? Because we know that we have a crowding out of private consumption, whether from households or investors. So the increase in government spending would lead to an increase in interest rate, because there would be an increase in the demand for money. Just remember why interest rate increases, because there is an increase in the demand for money. So once the demand for money increases, the demand for money shifts towards the right and interest rate increases. As interest rate increases, then we would have a fall in investment. Okay, so we say always that this increase would crowd out the investment spending, whether this is by households or firms. The tax rate is another multiplier. The one that we were discussing here is just a tax amount, right? But we can also have a multiplier that is related to the tax rate. So the tax rate would be something like this. We can call it the second type of multiplier. So let's write in black. So the tax rate is, again, we're writing the same, y is equal to c plus I plus g, assuming that we have a closed economy. And we're going to change the consumption function, assuming that the consumption function now depends on a tax rate but not a tax amount. So this c is going to be equal to a c bar plus MPC and a certain tax rate that is multiplied times income. Okay, so when you plug this into the function, plus I plus G, okay, and we are taking all the MPC, all the y in one side, so we're going to have y is equal to 1 minus MPC, right? 1 minus t is equal to c bar plus I bar. We can add the bars all the way because these are autonomous spending, right? And then g bar. And then we can write y is equal to 1 over 1 minus MPC times the tax rate, okay? And it's multiplied times c bar plus I bar plus g bar. In this situation, we can say, okay, what is the change in y because of the change in government spending, assuming that the government is using or is changing tax rate. So in that situation, the multiplier or the government multiplier is 1 minus MPC, 1 minus T. Okay? Right? And this is called the government multiplier under tax rate. The previous one was a tax amount. Okay? So here, for example, we're given some numbers, assuming that MPC is 0.75, taxes is 0.2, and using, or tax rate I should say, which is 20%. Using these numbers, you can plug it into this equation, right, and get that the multiplier is 2.5. So for each $1 increase in government spending, GDP is going to increase by 2.5. Now, suppose that taxes decreases. It was 20%, now it's 10%. We would expect that as taxes decreases, the multiplier is going to be bigger. Okay, number one, mathematically, it's in the denominator, right? There is a negative sign here, so it's positive. So the higher, the lower the denominator, the bigger is the number. And then number two, it makes sense that as tax rate decreases, people are spending more, so the multiplier effect is going to be bigger. So if we plug in 0.1 instead of 0.2, then we are going to see that the multiplier is bigger. Used to be 2.5, now it's 3.1. So for each $1 increase in government spending, output is going to increase about 3 times. We also have the last type, which is the open economy multiplier. Exports assumed to be autonomous, so we have a bar here, but imports depend on income. Okay, so we as consumers living in the US, we're going to import based on something called the marginal propensity to import. Okay, the marginal propensity to import is basically the change in imports due to the change in income. Okay, and this is called the MPI. All right. So here we're going to solve for the fourth type of multiplier. Okay, or I should say the third, because we combined the first one of tax and government together. So this one is an open economy multiplier with tax rate, right? So open economy multiplier with tax rate. So here we have our equation y is equal to c plus I plus G plus net exports. But then we start to open the C using tax rate, like the one that we had in the previous type of multiplier. So this one would be like C bar plus MPC 1 minus T times Y plus the I bar, right, plus G bar plus the X bar minus MPI, sorry, this is I, MPI times Y, right? MPI times Y, this is the imports, right? So now we need to combine all the MPCs and the MPIs, and anything that is attached to the Y, we need to just get it to the other side so we get a common factor Y. So if we take this to the other side, then I have a common factor Y, and I'm left with 1 minus MPC 1 minus T minus MPI, right, equal to C bar plus I bar plus G bar plus X bar, right? And you can end up by saying, okay, the open economy multiplier is 1 over 1 minus MPC 1 minus T minus MPI times C bar plus I bar plus G bar plus X bar. And then let's say you're asked to compute the government multiplier. So government multiplier, then it's like taking the first derivative of this formula with respect to G. So when I'm asking you, okay, what is the government spending multipliers, like what is the change in Y due to the change in G, and it's going to be equal just to this multiplier, right? So it's going to be equal to this formula of 1 over 1 minus MPC multiplied by the tax rate 1 minus T minus MPI. Okay, so looking at some numbers, so this is the government purchases multiplier in an open economy. Okay, assuming that the marginal propensity to import is 0.1 and assuming that tax rate is 0.2 and MPC is 0.75, you just plug in all the numbers, make sure that you work it in order so that you get the correct number. So you have here 1 minus 0.2 times 0.75 minus the 0.1, and I have a 1 outside, right? So this one would give us 2 as a multiplier. So for each $1 increase in government spending, the real GDP would be doubled. Now suppose that we have an increase in imports by marginal propensity to import by 0.2. It's like you're giving money out of the country, right? Then you would expect that the amount or the value of the multiplier to drop because you're spending more out of the economy. So the impact on real GDP would be less. So as the MPI increases, holding everything else constant, right? 0.75 is the same, the 0.2 for the tax rate is the same. The only thing that has changed is actually the 0.2, right? It was 0.1. So as the MPI increases, the multiplier or the open economy multiplier decreases. Okay? And this brings us to the last type of the multiplier. All right, so remember that just going to show you the first slide. So remember that we have basically three types. The very simple one with tax amount, the second one with tax rate, and the third one with tax rate and including net exports or open economy multiplier. All right, and this brings us to the end of the types of multipliers.